Hi, I'm Julian Ham, creator of Electricity Explained. If you've just been signed up by your head of department, you might be asking yourself what you've been signed up for. You've probably already got access to videos, animations and quizzes, so what makes Electricity Explained different? Let's try and answer that by looking at how one of your students might approach this basic question. What happens to the amount of heating if you increase the resistance of the bulb in this circuit? Without Electricity Explained, your student would have to choose one of these. 1. Do some maths. 2. Set up an experiment. Or 3. Use an analogy. Okay, let's use a formula a mathematically able student would use. P equals I squared R. If R goes up, then P goes up, so you get more heating, right? Wrong. I and R don't change independently. Current goes down when resistance goes up, and since I is squared, that has a bigger effect. So maths by itself won't always work. You need an understanding of circuits too. 2. Set up an experiment, either in the lab or using, for example, PhET. PhET gives you the right answer, but it only tells you a story about current, not energy. 3. Use an analogy. Let's use the rope loop.
And one last thing the teacher could do, picking on a pupil that you like, is you could ask them to hold the rope slightly tighter, and what will happen is as you pull it through, with it being a rope, you get a lot of friction, so you can talk about, well, a lot of energy has been transferred at the point where resistance increased.
Again, this is the exact opposite of how circuits behave. So the maths and the analogy would give the student the wrong answer, and the experiment wouldn't give them the full answer. The Electricity Explained circuit simulation gives you the right answer, and it's really easy to see what's happening. As you increase the resistance, you can see that the black dots, which represent single coulombs of charge, move slower. So energy, which is represented by the red stuff around the charges, gets shifted slower, and the expanding red circle around the bulb slows down, showing that heating happens slower. I'm not saying that charges really carry energy, but if you visualize it like this, then potential and power make much more sense. When you increase the resistance, the battery voltage stays the same, but the current gets smaller. And it's this kind of explanation that makes Electricity Explained different. All the videos, lessons and quizzes are based on a deep understanding of the physics of electric circuits, but presented in a way that's immediately intuitive and engaging for students across a whole range of abilities. In short, your students will understand circuits better with Electricity Explained.